Researchers at the National Institute of Standards and Technology, or NIST, wanted to find a better and safer way to measure objects through fire. They wanted to, quote, see through the flames. So, naturally, they torched a person. Nah, that's just a plastic toy skeleton. Or is it? The researchers used a laser detection and ranging system to capture the skeleton's complex three-dimensional shape as a 3D point cloud. They tried conventional video, but it was barely visible. These are optical range measurements that are already used in other fields like manufacturing, but now they can be used to measure structures as they collapse in fires. Using a commercial LiDAR system, the team was able to map the distance to objects melting behind the flames and soot within 30 micrometers or better. The researchers also melted a piece of chocolate. They wanted things that didn't melt too fast, and you can see how it deformed over 6 minutes. Now the team plans to scale up the project. The first tests were actually conducted on lab burners, so not exactly fighting through the flames in a wildfire. But the work could one day find its way into emergency response drones and humanoid robots that could use the system to identify objects and victims in fires that have otherwise run out of control. That means nothing. It's garbage. When you think body tracking tech, you typically think about athletes using the technology to improve their game, or at least capture their skills for a video game. Or maybe you just think about how Planet of the Apes was a CGI masterpiece without, an original concept among the bunch. Either way, the same technology has found a new application in the manufacturing industry. Ford assembly plant workers in Spain are now wearing sensor suits. The system tracks their movements on the line and is said to help promote good posture. And I'm sure nothing more, just focusing on posture. The pilot system is being used by 70 employees in 21 work areas at Ford's Valencia engine assembly plant. The system was developed by the Biomechanics Institute in Valencia. Ford is using the data to design workstations that are less physically stressful and make employees more comfortable. Oh, and they now have the ability to literally track your every move. The suit is skin tight and includes 15 movement tracking sensors that are connected to a wireless detection unit. For the sake of this study, the sensors are most focused on the head, neck, shoulders, and limbs. The data creates a 3D skeletal animation of the worker. So far, the study has been a hit, and Ford is actually considering rolling it out to other facilities. Still, the one question that remains is, it doesn't track you in the bathroom, right? Now, the conspiracy theorist in me sees a factory-wide rollout with sensor suits on every employee to maximize efficiency. But let's hope that, like other dystopian possibilities, it's just too cost prohibitive. That means nothing. It's garbage. Nikola, the company known for its electric semi-trucks and lawsuits with their shared namesake over the design of said semi-trucks, is in the news again. But this one, it doesn't have billion-dollar implications. Sorry, $2 billion implications. It's a costly one. The power sports side of the business has signed a contract with SoftWorks, a nonprofit collaboration between the United States Special Operations Command and the Doolittle Institute. The Tampa, Florida-based nonprofit, which is funded by Special Operations Command, is an incubator for new war tech. Nikola is going to take its 555 horsepower electric UTV that can go from 0 to 60 in 3.9 seconds, and it's going to try and find a way to make it autonomous, or at least semi-autonomous. The Reckless is modular and capable of being outfitted with various types of high-power weapon systems and mobility options. For example, you can choose between tracks or tires. Or for the roof, you can choose really big gun or not a really big gun. Under the contract, the Reckless UTV will have to be designed to perform in 4 different situations: unmanned perimeter security with remote monitor, a supply run, control recovery, and autonomous multi-vehicle missions. The vehicle will also support aerial and ground vehicles that will be able to interface with and deploy from the vehicle. And they need to have it all done by May 2019. That is a bold, aggressive timeline. I'm David Manti. This is Engineering by Design.